Welcome back to this quick setup guide for Datadog on Kubernetes. In the first part, we saw how to deploy an agent and its integration. Now we are going to go slightly deeper and visualize everything that this standard setup offers. Let's get started. At this stage, we've seen the fundamentals to deploy an agent and your first integration on a Kubernetes cluster. You should already see a lot of metrics reporting in Datadog just with a few minutes of work. Before moving forward, let's have a brief introduction of the Datadog cluster agent and why it is important in a Kubernetes setup. The cluster agent is a very important component in the deployment of the Datadog agent in a Kubernetes cluster. The first thing of interest is that a cluster agent helps us to remove some of the load on the Kubernetes API server. Indeed, it helps to centralize the collection of information about the cluster itself. This article called Introducing the Cluster Agent, written in 2018, gives a great introduction of this component. The diagram you can see explains how it was before. Before is the Datadog agent was deployed as a daemon set, and as you can see here, the agent was capable of collecting information from each container within each node because it was available on each node. But each agent had to also collect data from the API server, which was increasing the load on the API servers on large clusters. Since Datadog introduced the cluster agent deployed as Kubernetes deployment. On the architecture diagram, we can observe that the node agent are actually communicating to the cluster agent, and only the cluster agent is communicating to the API server. This makes the deployment a lot more robust and your system a lot more efficient. In addition to that, the cluster agent has a second purpose. The Datadog agent is deployed on each node via a daemon set, which means that if you have a service running on your Kubernetes, or if you want to monitor something external to your Kubernetes cluster, for instance, you want to monitor your MongoDB instance running somewhere else. Well, if you were to deploy it on the node agent, it would be deployed on all the node agents because it's a daemon set, so the data collection will happen multiple times in parallel, which is not useful. This is where cluster agent comes in. If you go with cluster agents, you have the ability to create what is called cluster checks. Those are checks that are managed by the cluster agent. The principle is to run the integration once per cluster every 10-15 seconds. It is now centralized and we avoid duplicating the calls. This is particularly relevant to monitor specific endpoints that you have outside of the cluster, or if you have a Kubernetes service to monitor once per cluster. In addition to that, the cluster agent includes an admission controller with multiple purpose. The main one would be to help change containers to start the monitoring of some components or enrich their configuration automatically. The concept of AutoDiscovery was briefly mentioned before. The main issue that we face in a Kubernetes cluster is that pods are moving between nodes. It is then more difficult to attach a configuration at the Datadog node agent level. So let me run through the concept of AutoDiscovery. The idea is on Kubernetes cluster, the pods keep going from one node to the other, whereas on the VM, we attach the configuration to the agent since we know the application will stay there. In Kubernetes, we then need to attach the configuration of the integration to the pod itself. And this is where we introduce the concepts of AutoDiscovery. Since the pod has the configuration of his integration attached to itself, it is possible for the node agent running on the same node to read such config and run the appropriate integration. It can detect which container to connect to and which parameters to apply. There are two main options available. The V2 is a lot more simpler to read, but both will work the same. In here we have this specific annotation that needs to be attached to the pod level where we have the name of the integration, the parameters init config, and the parameter instances. The text in array is useful if there are multiple containers running on the same pod that need the same integration. It is not very useful here. This way, you can deploy different integrations to the different containers and identify which containers to target. These parameters are the ones to select in here. We have Redis, which means that on the pod I would have a container called Redis as well. It is also possible to use AutoDiscovery and set it up at the agent's level. At the agent levels, you would define a way to identify the pod to target. For instance, set the name of the pods and containers to target and which integration to apply. This more complex configuration is often necessary when you are not the owner of the configuration of the pod, but you are the owner of the Datadog node agent. Since you still want to monitor those specific pods but no control over the deployment file, this way of configuring the integration gives you the ability to still monitor the relevant containers. Once the Datadog agent is running on a Kubernetes cluster, it collects a lot of information also available with the kube control command. In addition, since it is UI-based, a lot of shortcuts and links are made available. So what data does Datadog collect from your Kubernetes cluster? So if I go back to my cluster, I have now deployed quite a lot of containers and other assets running. Some of them are in error, we have some services, daemon set and others. What I'm more interested in is what Datadog collects. Just to confirm, we can still see the Datadog agent and cluster agent running. Those are actually collecting information about our cluster. If you go to the documentation, it indicates that the container view collects quite a lot of information. There is a view for container images. We can learn which images are currently running on your clusters, which ones take up much space, which ones are vulnerable if you enable security enable. But even if it's not enabled, you can see images by their tags and figure out if the old version are deprecated. We also have the orchestrator. If you ever imagine the ability to do some kube control command from your cluster about all the objects running, this is the place to do it. It could be useful for users who do not have direct access to your cluster or new users that are not yet comfortable with Kubernetes. It enables you to observe and navigate in a safe way and with visual aids to navigate between objects. It is very intuitive and easy to get started. The view on the resources is useful to validate the configuration of your objects, such as your pods. You can check if they are underutilized, under-provisioned, or over-provisioned. Let's have a look at that. We can go under Infrastructure, and here we have all of the information. Let's start first by the Kubernetes Explorer. At a high level, the Explorer lists all your Kubernetes objects. We can, for instance, focus on my Redis, and I will be able to see the YAML file for this specific deployment. It provides me the same information that kube control would provide me. In addition, the data is updated every few seconds. In addition, we can compare different versions, which is useful during changes. For instance, we can see what has changed between the two deployments. Apparently here, most of the things were identical. At the bottom, we can visualize the few things that have changed. In addition to that, if you are not familiar with how Kubernetes works, related resources is a very good place to look at. It helps you to connect everything. So my pod is part of this replica set, which is part of this deployment in this cluster and is running on this node. Everything is available in a single view. And if I would be interested in looking at what's happening as the deployment, I can click it, automatically getting redirected to the same views, but this time focused on the deployment. As you can see, it focuses on workloads deployments. We can see the new view, and we still have access to the YAML file. In each case, on the top, you can see the assets that are currently part of this deployment. For instance, here we can see the replica set. In my previous examples, we could see the containers running inside my pod. We also list all the tags associated with the object, its labels and annotations, and all of the other kind of information that helps you to navigate from object to the other. Some network information are also available at the pod level, the availability, etc. The orchestrator provides a very comprehensive view of your cluster with a lot of navigation help to explore and understand how things are behaving. In addition to that, because thanks to the unified service tagging, we can also look at the logs from this specific container or deployment. In this example, traces from APM could also be listed if it was ever collected, the metrics coming up from this object, some network information, and Kubernetes-related events as well. Those events are useful to troubleshoot when something is off, and you need to understand what Kubernetes complains about. You can see here previous container errors and also if some monitors were related to the specific pod itself. We also have a tab for Kubernetes overview. This is a very high-level view. Even if you're not familiar with Kubernetes, it will give you some common troubleshooting patterns and understand straight away some common issues that you could fix. They are provided automatically. Have a look at those whether you are new to Kubernetes or experienced. At the bottom, you will see all the recommended dashboards. These are dashboards that are provided out of the box for Kubernetes that will give you different ways to look at your clusters here at the pod level. It will show up in a few seconds. So here it will provide a pod-centered view, for instance, the number of pods running, if there are any issues, etc. And you can copy those widgets to use into your own dashboard. This dashboard is similar, but focuses on the overall view of the cluster. At the top here, as I promised, we can also look at the resource utilizations to figure out if my pods are using the resources in a proper way. So we can see that the CPU requests and usage requests are not set on my pods, which is not good to maximize the effectiveness of Kubernetes scheduler. In addition, in some cases, we are highly over-provisioned, so we can figure out ways to reduce that down. The last piece I want to show you on the infrastructure level about Kubernetes is the ability to look at the container images. In this view, we can see all the images currently running. This column shows the tags for each image, so you can see the versions actually running. If you have any security breach, you could quickly check if there are containers to update. If you were to enable the security product, you would also have some flags to tell that something is off. It is very good to bring security awareness and move towards DevSecOps. We can also see how many pods are currently using each image, when it was last used, its size, and all the information that you may need to troubleshoot and understand better your cluster. Great job! This session on Kubernetes is not the simplest one, but we covered the basics. We will dive deeper in some concepts in other videos. Already you should be able to fully take advantage of Datadog monitoring in your Kubernetes cluster and already increase your coverage. If you need more help setting up integrations or configuring advanced features, check out our other tutorials. Don't forget to subscribe for more tips and updates. Thanks for watching and happy monitoring.